Hi there and welcome to Penguin Learning. In this National 5 and GCSE Maths lesson, we are going to continue looking at trinomials and in particular how we can factorise a trinomial expression. In the last lesson we looked at examples where in the form of ax squared plus bx plus c, the a coefficient was equal to 1, but in this lesson we're going to have a look at expressions where the a coefficient is greater than 1. So for example, expressions beginning with 3x squared, 5x squared and so on. And to do this we're going to go over several examples that you can follow along with at home and improve your understanding on the topic of trinomials. So let's get started.
Ooh la la!
Okay, so in the last lesson we had on trinomials, we learnt that if we have an expression in the form of ax squared plus bx plus c, then we can use trinomial factorising to put this expression into two brackets. But more notably, we only chose expressions in which the a value or the a constant was equal to 1. An example of this would be the expression x squared plus 7x plus 12, where a is 1 because we just have x squared, b is 7 and c is 12. And we could factor this by saying that the first two terms in each brackets multiplied together have to be equal to x squared, and we said that would just be x, and the last two terms multiplied together would have to equal 12, but then also add up together to give the b term. In this case it was 7, and we said that if we have 4 and 3 multiplied together, that gives us 12, and added together gives us 7 here. And then what we can do is multiply out the brackets to check we had the same expression. So we would have x squared plus 4x plus 3x gives us the 7x, and then plus 12 to give us the last term at the end. But we must also think about how we can factorise trinomial expressions when a is greater than 1. So for example, if the first term is equal to 2x squared, 5x squared or 10x squared as an example. So let's explain it by going over an example where we have the expression 3x squared minus 7x minus 6, and we want to put this expression into a set of brackets, or in other words we want to factorise this trinomial. And some of the things involved in order to factorise this remains the same as if a was equal to 1. So if we just had a term here that was equal to x squared. For example, we know that in each set of brackets we're going to have two terms in each one and also a sign that connects them together, either a plus or a minus in each bracket. And we also know that because when we multiply out the brackets with two terms, we know that the first two terms in each of the brackets has to equal the first term in the original expression, so 3x squared, and the last two terms multiplied together have to equal the last term, so in this case minus 6. And we also know that the first two terms is going to be a value with an x in it, and the last two terms is just going to be a constant, or in other words just a positive or negative number. So the first thing that we have to think about is the possible combinations that can make up the first two terms. Or in other words, because a is equal to 3, we have to think what two whole numbers multiplied together equals 3. And we know that the only combinations for that is 3 times 1. So that means straight away we know that the first two terms in the brackets is going to just be 3x and 1x, which we just write as x, because we know 3x times x gives us the 3x squared needed up here. However, this next step is a little bit more tricky. Because in the past, when we said that a is equal to 1, all we could say to get the middle terms, or to get these two values, all we had to think of is what two numbers multiplied together gives the c term, but when added together gives the b term. But because now we have the a term in the bracket, which is 3, then when we multiply things together, this also has to be taken into consideration in order to get the b value. So also what I'm going to do before we think of how we can get this combination is write down the factors multiplied together which equal minus 6, okay? So for 6 we have 6 and 1 and 2 and 3, but for minus 6 we have to take into consideration the sign as well, okay? So we could have 6 and minus 1, we could have minus 1 and 6, we could have 2 and minus 3, and minus 3 and 2. And alongside the signs that we have to be careful for, we also have to be careful where we put these numbers in the brackets, because let's say it was 6 and minus 1 for example. if we had 6 here and minus 1 here, that would be a different answer than minus 1 and 6 here, because we have the 3x and x in the brackets, and that's going to produce different values when we multiply together, because in the past it was only x and x we had here, so that means it didn't matter in the order these were, because the first terms were the same, but because they're different in this case, the order in these numbers also matters. Okay, and the way that we check, or the way that we decide what two numbers go in where, we have to perform the little cross multiplication that would happen if we were to multiply out the brackets. Okay, so we know that the first two coefficients are 3 and 1, so these don't change, okay? But then what we have to do is test all of the factors of minus 6 and the combinations we get when we do a form of cross multiplication. What I mean by that is what we do is cross multiply these two numbers and these two numbers and add them together, and the right combination should give us the answer, the b term, which in this case is minus 7, okay? So to begin with this set of example, we have 6 and minus 1 in that order. 3 times minus 1 is minus 3, 6 times 1 is 6, add them together, we get positive 3, so we know that's not right. And if we swap them around, we have 3 times 6 is 18, minus 1 is 17, so that's also not right. And one thing we can also tell is that if we flip the sign, so in this case we make it minus 6 and positive 1, then we still aren't going to get the same answers, because this time what the resultant value is just the negative of what we had the last time. So the last time we had 3 and 17, this time we have minus 3 and minus 17. So that means we know the combination of numbers isn't any of these ones here. So in this case it must be 2 and minus 3, or minus 3 and positive 2. So let's say this time we have 2 and minus 3, so 2 on the top, minus 3 on the bottom. We would have 3 times 3 is minus 9, and then 1 times 2 is 2. Minus 9 plus 2 is going to give us the minus 7 that we're looking for. Okay, so now we've found that answer, now we've got the right b value. What that means, in this order, we put the 2 in the first bracket because that's in the top, and we put the minus 3 in the second bracket because that's on the bottom. So that means the completed brackets will look like this. We'll have 3x plus 2 and x minus 3. Okay, and now what we can do is check this to see if we got the right answer. Multiplying the two first terms together, we have 3x squared, because 3x times x is 3x squared. The two outside terms is minus 3 times 3x, which gives us the minus 9x. The inside terms is plus 2x, and multiplying the two last terms together, 2 times minus 3 is minus 6, and then when we add both of these together, minus 9x plus 2x is indeed going to give us the minus 7x. So that means this has been factorised correctly. So again, the key thing is thinking of the right combination of the first terms and last terms when cross multiplied together, which gives us the same middle term here, which in this case was minus 7. Okay, so let's have a look at this next example where we have the expression 4x squared plus 8x minus 5, and we want to put this trinomial again in a set of two brackets. So we know that the first two terms have to equal 4x squared when multiplied together, and the last two terms have to equal minus 5 when multiplied together. Okay, so what we have to think of first of all is what are the two first terms in each of the brackets that can equal 4x squared? Well, we know that the possible combinations this time would be 4x and x, but we could also have 2x and 2x this time as well. So we have to analyse these two possible combinations. And we know that for the last terms, for minus 5, well, we know that the only two options would be minus 5 and 1, or minus 1 and 5. And again, the order for these last terms matter as well. Okay, so another possible combination would be 1 and minus 5, and 5 and minus 1. So the order matters for these last two terms. And the way that we figure out which is which, what we have to do is cross multiply the terms in each of the brackets, and the resulting answer should equal the b term, so in this case 8x. So the first combination, we have 4 and 1 minus 5 and 1. 4 times 1 is 4, minus 5 times 1 is minus 5. 4 minus 5 is going to give us an answer of minus 1, so that's not correct. And if we do it the other way around, 4 times 5 is minus 20, 1 times 1 is 1, minus 20 plus 1 is going to give us minus 19. And then because we found out what these two answers were, because none were minus 8 or anything like that, we know that the combination we have here is just not right. So the only way we can change it again is by doing different numbers at the start. So replacing 4 and 1 with 2 and 2. So if we do that, we know 2 times minus 5 is minus 10. 2 times 1 is 2. Minus 10 plus 2 is minus 8. That's not the answer we're looking for, but the number is the same, only this is a negative version. And all that means is we have to swap the signs for the minus 1 and 5. So then we have 2 times 5 is 10. 2 times minus 1 is minus 2. 10 minus 2 gives us the 8 that we're looking for. So now we've found that, now we know which numbers go in the first bracket and the second. The first bracket are these terms here, so 2 and minus 1. And we know that the first term always contains an x, so it's going to be 2x minus 1. And then for the second bracket are these numbers down here, so 2 and 5. So that means that's going to become 2x plus 5. So in the first bracket, 2x minus 1, and in the second, 2x plus 5. And again, it's always worth checking to see if it's the right answer. So 2x times 2x multiplied out is 4x squared. The outside terms is 5 times 2x, which is 10x. The inside terms is minus 1 times 2x, which is minus 2x. And then minus 1 times 5 is minus 5. And then we know that these terms here, so a plus 10x minus 2x, gives us the 8x that we're looking for up here. So that's 100% correct. Okay, let's have a look at one final example, and this expression is 10x squared plus 38x minus 8. So you might be tempted to just go ahead and start doing the trinomial factorising method that we've been working on in the past 2 lessons. But remember, what is the first thing that we always look for when we go to factorise? The answer, yes, is a common factor, okay? So in the last few examples we've just did there wasn't a common factor between the A, B and C term, but if we look at this expression, we have 10, 38 and minus 8. And what do all these numbers have in common? Well, they're all even numbers, and that means they can all be divided by 2. So to begin this example, I'm going to take a common factor out of 2, and that will leave us this time with 5x squared, because 10 divided by 2 is 5. 38 divided by 2 is 19, so that will give us 19x, and minus 8 divided by 2 will give us minus 4. So that means we have outside the brackets 2, inside the brackets is 5x squared plus 19x minus 4. And now what we're left with is a trinomial which doesn't have any common factors between the terms, so between 5, 19 and minus 4. So now what we can then do is try and factorise this even further by using the trinomial method that we've been working on. So thinking of what first 2 terms multiplied together will give us 5x squared. Well, we know that the only 2 numbers that can be multiplied together to give 5 is 5 and 1, because 5 is a prime number. So that means straight away we know that the first 2 terms in each of the brackets will be 5x and x. Now for the last term here we have minus 4. So we have to think of all the combinations multiplied together will give us minus 4. And these would be 4 minus 1, minus 4 1 and minus 2 2. And now we have 5 1, and any combination of these when we cross multiply has to equal 19, okay? And just to speed things up, it doesn't always have to be just trial and error. As you practice with these a little bit more, you start to get a sort of feeling for what a combination might be. So what I mean, for example, is we know that the options here are 4 1 and 2 and 2. That means we can start thinking of possible combinations that's going to give us the value of 19, okay? The first thing that we can notice is that 19 is a positive number, and quite a large one when doing these sort of sums, okay? So that means we know that whatever multiplication, whatever the bigger one is, that has to be the positive one, and the smaller one has to be the negative one. Because if the bigger multiplication is positive and the smaller one is negative, that means it's going to give us a positive answer. The next thing that we can think of is possible combinations of multiplying things in our head. One thing that we know straight away is that 5 times 4 gives us 20, and 20 is only one off the answer of 19 that we're looking for, okay? So what we can say then, or try, 5 times 4 is 20, then to get 19 we need a minus 1, and that's the exact combination which we have. We have 4 and minus 1 as a possible combination. So that means if we do 5 times 4, that's 20, 1 times minus 1 is minus 1, 20 minus 1 gives us the 19 that we're looking for, and that means we can fill in the brackets in that order. So we have 5 and minus 1 in the first bracket, so so that becomes 5x and minus 1. And in the second we have 1 and 4, so that's going to be x and positive 4. And then finally, let's just multiply these brackets out. We'll have 5x squared, we'll have plus 20x minus x, which gives us the plus 19x, and then minus 4 at the end. Minus 1 times 4 gives us minus 4. So if we take a step back and think of, first of all, what could be a more realistic or more likely combination of numbers, instead of just diving in and trying every possible combination. That way we can maybe save a little bit of time if we were given such a question in an exam. So I hope this lesson on factorising trinomials has been helpful to you and your understanding on the subject, and if that's been the case, consider liking the video and subscribing to the channel for future videos. If you have any questions on this lesson, drop a comment down below and I'll get back to you as soon as possible. And as always, thanks for watching the video and I'll see you in the next lesson.